This video shows how to configure PID controller with ABB ACS480 general purpose drive. First, we enable the PID macro. Next, we select the control reference to come from the PID controller. PID macro uses run enable signal, which is connected to DI5 as default. Digital input 1 is set to control starting and stopping of the drive. Run permissions can be set, for example, to prevent false start. Here we set the drive to stop and prevent start when digital input 5 is inactive. Primary settings embeds PID submenu that holds specific settings for PID controller. User can freely edit the name of the PID unit. Here we put percentage symbol. Next, we define analogic input 1 to be the source for the PID set point. Analogic input 2 is set to be the source for the process feedback. Integration time needs to be set to the same order of magnitude as the reaction time of the process being controlled. Otherwise, instability will result. In applications where the demand changes as a function of time, for example, PID sleep function can be used to save energy when the demand decreases to the level it is worth to shut the pump, for example. When used, sleep function stops the pump completely during low demand, instead of running slowly. PID sleep time can be extended using boost functionality. The boost functionality increases the process set point for a predetermined time before the drive enters the sleep mode. The ACS480 firmware manual includes a distinct figure that explains the functions of these parameters. Next, we edit the home view so that we can monitor process PID feedback while monitoring other signals at the same time. We set the value of feedback to be shown in the lowest part of the display. Now let's test the functionalities of the PID controller. When the reference and the feedback are the same, the output stabilizes to the value where reference and feedback matched. The process PID controller adjusts the drive speed in order to keep the measured process quantity at the desired level. drive adjusts its operation according to the process PID. Next, we simulate low capacity demand. When the capacity demand decreases below 5 Hz for 2 seconds or more, drive goes into sleep mode. When the demand rises above the set activation limit, the drive starts again. Thank you for watching. For more information, please visit our website.